Beneath the Alps, engineers confront challenges hidden from view. The Gotthard Base Tunnel connects northern and southern Europe, carrying trains silently through solid rock.
For centuries, the Alps stood as Europe's greatest natural barrier.
These mountains did not welcome crossing. They punished it. Trade routes climbed narrow passes where weather determined survival. Journeys measured in weeks could extend to months when storms arrived. The Alps did more than separate land. They separated economies and cultures.
Beneath the surface, geology tells a story of pressure and time.
The Alps generate weather as unpredictable as the terrain itself. Winter could close passes for months, severing connections completely.
Those who crossed faced altitude, cold, and consequence.
Human ambition ended where the mountains began. Direct routes existed only on maps, not in reality. These rocks remember the collision that created continents. Ice and time shaped valleys that channeled movement for centuries.
Summer offered windows of possibility that winter erased. Seasons dictated what was possible and when.
The mountains claimed those who underestimated their indifference. Geography determined prosperity as much as human effort. Water moves through the Alps on timescales measured in centuries.
The Alps permit certain movements while forbidding others.
The pressure that built these mountains remains locked in stone. Every crossing required preparation that acknowledged risk. Beauty and barrier existed together in these mountains. One location offered the most direct path and the greatest challenge. For centuries, the Gotthard stood untouched and unconquered. The first solution was to climb, to force trains over the summit.
Gradients demanded maximum power for minimal speed.
Engineers created spirals inside mountains just to climb higher.
The first tunnel offered passage, but remained bound to elevation.
Winter closed the route for months, severing the connection.
Speed was sacrificed to altitude. Distance became time lost.
The mountains extracted cost with every meter of elevation gained.
Human labor could not match the pace of mountain weather.
Geography created inequality. Flat routes prospered, while mountain routes struggled. Descending tested brakes as much as climbing tested engines.
Every route attempted the same solution and faced the same limits. Physics demanded energy to climb and offered nothing but risk descending. Failure at altitude meant stranding passengers where help was distant.
Seasonal closure made the route a sometime solution to a permanent need.
Engineers recognized that optimization could not overcome fundamental constraints.
The mountain route became a choke point, limiting what Europe could become. Demand grew while capacity remained fixed by geography.
Debates shifted from how to improve to whether improvement was possible. Every proposed improvement encountered the same barrier: altitude.
Complexity increased with every attempt to make the climb manageable.
The solution existed in theory, avoiding elevation entirely. Power could not defeat the mountain, but depth might bypass it. In the 1990s, engineers proposed something different, not over, but through.
The new route would cut 500 meters deeper than any previous attempt. 57 kilometers would be carved beneath the Alps. Before drilling, engineers needed to know every meter of hidden geology. 5 access points allowed tunneling from multiple directions simultaneously. 2 kilometers of mountain would rest above parts of the tunnel. The project would span nearly 2 decades of continuous work. Switzerland committed resources on a scale unprecedented in its history. A nearly flat path would replace gradients that defeated locomotives. The tunnel would cut through a dozen different rock formations.
Predictions could guide preparation, but not eliminate uncertainty.
Every component would face conditions beyond previous experience.
Two separate tunnels ensured safety if emergency required evacuation. Success demanded that 2 holes through mountains align within centimeters. In 1999, preparation gave way to action at the northern entrance.
At the southern entrance, an identical preparation unfolded in parallel. A vertical shaft descended 800 meters to allow work from the mountain's center.
When drilling began, decades of planning met the resistance of stone.
Machines weighing thousands of tons would advance meters per day.
5 separate tunneling operations advanced toward predetermined meeting points.
The mountain became a construction site without a single surface.
Alignment depended on technology, measuring movement in millimeters across kilometers.
Within the first kilometers, granite, harder than expected, slowed progress.
Cutting tools wore faster than anticipated, requiring constant replacement.
Deep inside the mountain, rock temperature exceeded human tolerance.
Cooling systems fought constant battle against the mountain's interior heat.
Water found paths through rock, arriving under pressure that demanded immediate response.
Pumps removed thousands of liters per minute in sections where water never ceased.
Fault zones appeared where surveys predicted solid rock. Unstable zones required support systems stronger than initial designs specified.
2 kilometers of mountain pressed inward with force that never relaxed. Support structures deformed under load, but maintained integrity where failure meant collapse.
Every meter required monitoring systems that detected problems before they became failures.
Progress paused where conditions demanded new approaches rather than continued force. Probe drilling revealed conditions ahead, allowing preparation before encounter.
Each challenge followed a pattern: encounter, understand, adapt, advance.
Predictions guided planning, but reality determined schedule.
Human shifts changed, but the mountain's resistance never rested. Geology provided warnings that engineering translated into preparation.
2 machines carved toward each other through kilometers of unknowable rock.
Where water persisted, permanent barriers contained flow without stopping work.
Challenges appeared throughout the length, never predictable in sequence or severity.
Plans evolved as knowledge replaced assumption.
The mountain rested on the surface while resistance and response continued below. Lasers measured position constantly, translating light into data into adjustment.
Surface satellites guided machines buried kilometers below. Deviations measured in millimeters were corrected across distances measured in kilometers.
Steering systems adjusted constantly, maintaining direction through resistance that never aligned perfectly.
Gyroscopes maintained orientation where external reference became impossible.
Traditional surveying verified electronic systems, ensuring no single point of failure. Success required meeting within a target zone smaller than a car.
As separation decreased, precision became more critical than ever.
When the tunnels met, celebration acknowledged not drama, but mathematics proven correct. 5 to 7 kilometers were aligned with error measurable in centimeters. The error was smaller than a step over a distance spanning nations.
The meeting represented years of precision maintained by thousands of people.
Breakthrough began the final phase, transforming excavation into infrastructure.
Ventilation systems would sustain life and remove heat from trains passing through.
Track alignment matched tunnel precision. Smoothness at 250 kilometers per hour demanded it.
Safety systems were tested until failure became implausible.
Cross passages ensured safety regardless of which tunnel faced emergency.
Final inspection verified that reality matched design across every meter.
The first train confirmed what 17 years of precision promised.
Data confirmed performance. Every system responded as calculation predicted.
On the surface, the mountain revealed nothing of the precision achieved beneath.
Opening ceremonies acknowledged a victory of calculation over circumstance.
Trains now cross the Alps in minutes, not hours.
Passengers cross beneath mountains without awareness of depth or complexity. Freight moves through the Alps as if the barrier never existed.
Journey times contracted, as if distance itself had been reduced.
1 million trucks per year avoided mountain roads, their cargo moving underground instead.
Alpine routes became passages for people, not containers. One tunnel connected networks that serve a continent. Economic exchange increased as capacity replaced constraint.
Communities gained connection without surrendering tranquility.
Operation requires constant attention that remains invisible to users.
Reliability demands maintenance that users never see, and never should.
Capacity built for decades is used every hour of every day.
Every year, the tunnel prevents emissions equivalent to hundreds of thousands of cars.
The tunnel teaches engineers who will face challenges yet unnamed.
The world acknowledged an achievement that redefined what infrastructure could accomplish.
The entrance announces nothing. The achievement requires no monument.
The entrance announces nothing. The achievement requires no monument.
From above, the Alps reveal nothing of what lies beneath.
Nature and infrastructure occupy the same space without displacing each other.
Day after day, trains cross while mountains stand, both permanent, both serving.
What connects cities exists at a scale that transcends nations.
Beneath the surface, human ingenuity carves paths for the future, quietly shaping Europe.